Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for search insert position problem. Let's look at the problem description. We are given a sorted array of distinct integers and a target value, and we have to return the index of the target value if it is present. If it is not present, we have to return the index where it would be if it were inserted in order. Also, we are expected to write an algorithm with the order of log n runtime complexity. Let's take a look at the example 1. The input array has 4 elements 1, 3, 5, 6. The target value is 5. The 5 is located at index 2, so the output is 2. In the case of example 2, the target value is 2, but the 2 is not present in the input array. But if we insert this into the array in a sorted order, then it will be positioned at index 1. So that's why the output is 1. In the case of example 3, the target value is 7, which is not present in the input array. That value is greater than all the elements present in the input array. So if we insert this element in order, it would be positioned at index 4. That's why the output is 4. The constraints for this problem are the length of the input array is ranging from 1 to 10,000, and the value of the number will be minus 10,000 to 10,000, and the nums array contains distinct values in a sorted order. Okay, and the target value is also ranging from minus 10,000 to 10,000. Let's look at the approach to solve this problem. We are given an input array with 4 elements 1, 3, 5, 6. The target value is 5. So the target value is located at index 2. So the expected output is 2. Okay. We can search the target element in the input array linearly. Starting from the index 0, we can check all the elements in the input array. If any of the element matches with the target value, we can return the corresponding index as the output. If none of the element matches, we compare the target value with the first element. If the target value is less than the first element, we return 0 as the index. If the target value is greater than the last element in the input array, then we can return the last element index plus 1 as the output. So for this approach, the time complexity is order of n, but we are expected to solve this problem with log n base 2 time complexity. For that, we can use the binary search algorithm. Basically, we maintain two pointers, start and end. Start points to the beginning of the array, end points to the end of the array. Each iteration, we compute the mid index, and then we compare the target value with the value present at a location pointed by the mid index. Okay, so if the target value is less than the mid value, then we can adjust the end pointer to point to the element before the mid element. Okay, if the target value is greater than the mid element, then we update the start pointer to point to the next element followed by the mid element. Okay, we repeat this process until the start and end crossed each other. During that time, if the target value matches the element pointed by the mid pointer, we return the mid pointer as the output. Each iteration, we compare whether the target value is less than the value pointed by the start pointer. In that case, we return start pointer as the new index value for that element. If the target value is greater than the element pointed by the end pointer, then we return end pointer plus 1 as the new index of that target value. So that's what I have written here. We can solve this problem using the divide and conquer approach. First, we initialize the start and end pointers to point to the first and last element in the input array. Then initialize the index to -1. Then traverse the input array until the start and end pointers cross each other. Each iteration, compute the mid pointer, and if the target value is less than the value pointed by the start pointer, then return the start pointer as the index for the target value. If the target value is greater than the element pointed by the end pointer, then we return n plus 1 as the index for that target value. Next, we are reducing the search space by comparing the value pointed by the mid pointer with the target value. If the target value is less than the mid value, then we adjust the end pointer to point to the element 1 before the mid element. If the target value is greater than the mid element, then we adjust the start pointer to the element next to the mid element. If the target value matches the mid element, then we return the mid as the index of that target value, and finally we return the index. So each iteration we reduce the search space by 2. So that's why the time complexity for this approach is log n base 2. Let's look at the flowchart. Input for this procedure is nums array and the target value. First we initialize the start pointer to point to the first element, the end pointer point to the last element, and the index value is initialized with -1. Then we check whether the start is less than or equal to end. If start is greater than end, that means they crossed each other, so we break out of the loop. Otherwise, we compute the mid pointer and then we check whether the target value is not present in the range starting from start and end by comparing if the target value is less than the element pointed by the start pointer, then we set the index with start pointer and break out of the loop. Else, we check whether the target value is greater than the element pointed by the end pointer. If that is true, we set the index with value n plus 1 and break out of the loop. Otherwise, we check whether the target value is less than the element pointed by the mid pointer. If that is true, we adjust the end pointer with mid -1. Otherwise, we check whether the target value is greater than the element pointed by the mid pointer. If that is true, we set the start pointer with mid +1. Otherwise, the target value matches the mid element, so we assign the mid pointer to the index and break out of the loop. And finally, we return the index as the output. Let's move on to coding. First, I initialize the start pointer to point to the first element in the input array and the end pointer to point to the last element in the input array. And then I initialize the index with value -1. Then I write the for loop to traverse the input array from the beginning and the end. This for loop runs until the start crosses the end pointer. Each iteration I compute the pointer to the middle element in the range starting from start pointer to the end pointer. Then I check whether the target value is less than the element pointed by the start pointer. If that is the case, then I set the index value with the start pointer's value and then break out of the loop. And then I check whether the target value is greater than the element pointed by the end pointer. In that case, I set the index value with n plus 1 and break out of the loop. Next, I compare the target value with the element pointed by the mid pointer. If the target value is less than the middle element, then I update the end pointer to point to the element previous to the mid element. Otherwise, if the target value is greater than the middle element, then I update the start pointer to point to the element followed by the middle element. If the target value matches the middle element, then I update the index with the mid pointer and break out of the loop. And finally, I return the index value. Next, I'm going to run the test cases. All the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. The input nums array has 4 elements 1, 3, 5, 6. the target value is 5. The expected output is 2 because the target value 5 is located at index 2. Okay. So first we initialize the start pointer to 0, end pointer to the length of the array minus 1 and the index to minus 1. So the start pointer is 0, end pointer is 3, the last index in the input array, and then the index value is initialized with minus 1. So in the iteration 0, we check whether the start is less than or equal to end. In this case it is true, so we enter the for loop, compute the mid pointer by adding start plus n minus start by 2, which gives us value 1. So the mid pointer points to the value 3. Okay. Then we compare whether the target value is less than the element pointed by start. In this case it is false. And then we check whether the target is greater than the element pointed by the end pointer. In this case it is false. So we go ahead and compare the target value with the mid element. So the target value is 5, the mid element value is 3. So the target value is greater than the mid. So we adjust the start pointer to point to the next element followed by the mid pointer. So the start pointer is updated with 2, mid plus 1. Okay. And in the next iteration we compare the start and end pointer. Still the start is less than end pointer. So we go ahead and compute the mid pointer. So the mid pointer in this case 2 plus 3 minus 2 by 1, we get 2. So the mid pointer points to the element at index 2. Again we compare the target value with the element pointed by the start. So in this case the target is not less than the element pointed by start. We go ahead and check whether the target value is greater than the element pointed by the end pointer. In this case that is also false. Then we compare the target value with the element pointed by the mid pointer. Okay. First we check whether the target value is less than the element pointed by the mid. In this case it is false. Then we check whether the target value is greater than the mid. That is also false because both are equal. So because both are equal, we set that mid pointer to index. So the mid pointer is 2. So we update the index value with the mid pointer value and then break out of the loop and return the index as the output. So the current index value is 2. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of log n, where n is the number of elements in the input array. Okay. Let's take a look at the case 1 where it has 4 elements and the target value is 5. So for this input, let's see how many iterations this for loop performs. So as per the code walkthrough, we saw this for loop perform 2 iterations. Okay, because every iteration we reduce the search space by 2. Okay, the first iteration we look at the region starting from the index 0 to 3. The next iteration we do start from the index 2 to 3. Okay, so in the second iteration we found the index. Okay, so this for loop performed 2 iterations, which is log 4 base 2. Okay, so if there are n elements in the input array, this for loop performs log n base 2 iterations. So that's why the time complexity is order of log n. Space complexity is order of 1 because we are using only few variables. There is no additional space allocated to find the index. So that's why the space complexity is order of 1. Thanks for watching this video. Have a great day.